Welcome everyone to our DT&L Talk webinar series sponsored by the University of Wisconsin-Madison's Distance Teaching and Learning team. These free webinars are 30 minutes or less and focus on one big topic in technology-enhanced learning. My name is Tom Tobin, and our colleagues Jenny Peabody, Bridget Powell, Bill Tischler, and Miranda Winkleman are here to support everyone on the live session today. We're going to be using the chat feature for interaction. So if you hover your mouse over the bottom of your screen, you'll see a number of controls. The one that you're looking for is a round button with a speech bubble in it. That's a way to pull up the chat feature, and that's the way that we'll be interacting today. We're very happy to introduce today's DT&L Talk presenter, Rae Schroeder. Dr. Schroeder is a senior fellow of the University Professional and Continuing Education Association, or UPSEA, and he is professor emeritus and associate vice chancellor at the University of Illinois, Springfield. He's been an active participant in the DT&L conference since the 1980s. A recipient of numerous national awards and citations for individual excellence and leadership in our field, Rae is a noted speaker, consultant, researcher, and author on topics related to online learning, emerging educational technologies, and technology-enhanced learning as well. We're happy to have Rae with us to talk about the quantum promise of artificial intelligence. This is a preview of his invited talk at the Distance Teaching and Learning Conference, August 4th through the 6th of 2020. Welcome, Rae.
Well, thank you so much, Tom, and it's a pleasure to join you all. This is a tremendous opportunity for us to get together, even as we talk about the wintry weather that surrounds us all. So I have a number of things to share with you. I'll bring up this screen, and I think we have it now. First, a word or two about PowerPointless, with the emphasis on pointless. For the past dozen years or so, I've presented at conferences and webinars and the like, really without PowerPoint, which I see as more of a two-dimensional medium, one that cannot easily be changed. And instead, I try to develop web pages such as this one. So the goal is that you be able to take this URL and use it for faculty, staff development, otherwise any way that you might be able to find to use the resources and repurpose them. Don't mention me, just take them and use them. But I will continue to update this page on occasion and until our conference, and at which time it will have expanded significantly, I think. So that's the background on the presentation format. This new decade in which we have just emerged is truly the decade of AI and quantum. I had written in Inside Higher Ed a couple of months ago, make no mistake, we've crossed the threshold into the fourth industrial revolution that will most markedly advance this decade through maturing artificial intelligence, ultimately by the end of the decade to be driven almost exclusively by quantum computing. And we'll talk a good bit about these technologies over the next 20-25 minutes. But in a retrospective, when I look back to the years that I taught a graduate seminar in new and emerging technologies in the electronic media, we had a steady parade of technologies. For example, cellular radio, which then became cellular phones. And we saw how technologies moved. And while they seemed to be incremental, they were, but as they moved in just forward, every year it multiplies upon itself. And so if we were to cast ourselves back 20 years, we would certainly miss many of the technologies that we now have. And as we project ourselves into the future, we're going to see some significant new technologies that will make huge differences in the way in which we deliver education. So let's begin with a few definitions. Artificial intelligence. That's really the theory and development of computer systems that are able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision making. There's just, multiple languages. So AI allows us greater facility than we're used to from computers. Machine learning, we talk about, well, what's machine learning? It's really an application of AI that allows for systems to automatically learn, absorb, and improve their performance without being explicitly programmed. So we create, computer engineers create an algorithm that then is implemented by the computer program, and it's able to improve itself over time. And that's different than what we've had previously. Deep learning is where things get much more interesting. It's a subset of machine learning, and in fact, deep learning is machine learning that functions in a way that sometimes are loosely interchanged, but its capabilities are different. The basic machine learning models do become better at whatever their function is, but they still need some guidance. If an AI algorithm returns an inaccurate prediction, then an engineer has to step in and make the adjustments. With a deep learning model, the algorithm can determine on its own if the prediction is accurate or not. So with deep learning, it begins to grow and grow and grow and improve on its own without supervision. Algorithm is really just a list of operations that could be done in a machine, a Turing machine. For the purpose of computing, algorithms are written in flow charts and pseudocode and the like. Um, Python, is an example of how one might program those algorithms. Supervised and unsupervised learning is, and this is again machine learning, not students learning, although I suppose the machines are students. In a supervised learning model, the algorithm learns on a labeled data set, providing an answer key that the algorithm can use to evaluate its accuracy. In an unsupervised model, it has unlabeled data, just a mix of data, video and digital, well, I mean, video is digital, but numeric data and whatnot, and it extracts the patterns on its own. One of the key pieces of AI now is trying to determine cause and effect, not just that it might be a concurrent occurrence, but what truly causes what effect. And so many of our questions are in that regard, like the current coronavirus. What's causing these symptoms? Why are some less severe? Why are some more severe? Enabling AI, we may be able to determine ways that we can alter that virus to make it far less virulent. Well, I'm not going to go through the videos associated here, but I'm going to remind you that now that you have that URL, and we'll share it again at the end, but that you'll be able to go through the basic explanation of AI in 101 seconds and the like. With artificial intelligence, we really need to begin to approach this whole area with perhaps some more caution than we have with other technologies. So your IRB in your institution gets proposals commonly, and the research board moves forward, but they need to be informed, and perhaps it's our role to inform the IRB of some of the ethical concerns of AI. It's not that AI is going to be a killer, literally killer technology, but it is that there are all kinds of social ramifications, privacy ramifications, and the like. So there are challenges as well as benefits to using AI. And certainly, I think the benefits outweigh the challenges, but we cannot ignore those challenges. I love a good example that was given to me by some engineers who were working on autonomous cars, which are, of course, driven by AI. And they said that they were grappling with this scenario. They have to present scenarios to the software for those cars so that the cars can then make decisions, or the software can make decisions. So the one scenario is a one lane, one way street, keeping it simple. On the right side is a little girl doing in playing hopscotch, and on the right side, let's say, and on the left side, a telephone pole. If the car hits the telephone pole, your occupants are hurt or killed. And the the third piece to the scenario is there's an elderly guy like me walking across the street in front of the car. The car cannot stop in time. It has to go right or go through the old guy or hit the telephone pole. And making those decisions involve cultural, social, and perhaps in some cases, gender um, considerations. And these values need to be represented in autonomous vehicles. And so many universities have participated in the autonomous vehicle development process that, this is just one small example of the ramifications that we need to look at. Perhaps more commonly, it is, gosh, if we can take all of the historical learning data from our students in the university back to third grade and how they performed on those aptitude and achievement tests, we would be able to better drive adaptive learning for that student. But in doing so, are we violating their privacy? And so once again, that's an area in which we're going to have to begin to do some deep thinking. Well, there's a sampling of areas where we're already using artificial intelligence, and I mentioned this first one that came out yesterday in Technology Review, an MIT publication. But Google has released a new neural network powered chat box called Mina that it says is the best of the class. Um, they have dumped in 341 gigabytes of public social media chatter, much more than any other such chat box. And then Mina can make up, as they call them, bad jokes, but nevertheless, um, but they're using it as a chat box to emulate a human, and there are all kinds of applications to that. One of the pieces that I often talk about is the digital assistant. And we're all familiar, with Alexa and Hey Google and, all the various digital assistants. But maybe we haven't thought how students can, and perhaps some already are using it. I'm sure some are. And that is, perhaps you're taking a class in epistemology and you need to do a research paper, and it's due at 4 o'clock this afternoon. Has to be 12 pages, 10 annotated bibliography sources, and you're given the topic. Well, you give that to your assistant, right? So you just say, hey, Google, I need a 12-page paper. I need 10 annotated bibliographic sources. It's got to be APA style, double spaced. The topic that I'm looking at is thus and such. Please send that to me in PDF format and print and send it to the printer too. I need it by 3:30 so I can bring it to class. So those kinds of things are happening already at one scale or another, not in open commercial ventures, but certainly among those in computer science and information systems. Those kinds of technologies are there. And what does that mean for us in the professoriate, for those who are teaching, what does that mean? So how do you craft uh, opportunities or challenges for research for your students when you know that they can farm this out virtually, right? It's outsourcing. They can outsource the assignment to a digital source. And one might suggest, oh, well, yeah, but I could tell about their writing. I'm going to go ahead and skim down and then I'll come right back because I want to note that you're reading AI reports every day. Um, Bloomberg reports 1/3 of all its news reports are written by AI. The Washington Post, Forbes, Guardian, AP, they're all using AI generated news reports. And here are those reports from the New York Times, Forbes, and uh, Technica. So this is already happening. The software is there to write rather well. When we look broadly across our field of education, AI musicians have emerged. And, and that's kind of interesting because not only do they write their own music, but AI performs the music and the videos. So here are three examples. I'm not sure how that works for you, but uh, but the music industry is going to be influenced by AI taking the trends and AI emulating what it sees as appropriate musical syntax, formats, genre, and the like. Um, Siraj Raval describes how that takes place at this URL. Um, so there are also sites that summarize research for faculty and students. Essay graders, particularly at the K-12 level, have been around for years. AI has passed science tests, and not just factual ones, but ones that require reasoning, and that's kind of interesting. Essay bot will write your student essays for you, um, and of course, then the news reports that are written. AI can design classes even now. Um, so you provide the subject matter materials and information about the students and the students' background, and they can design classes. Probably the most important aspect of this all is adaptive learning. Candace Till, back at Carnegie Mellon and Stanford, and now she went to, is it Amazon? I think, yeah. Um, it's really kind of the godmother of adaptive learning, where a program determines, based on the way in which the student responds to questions, creates branching. It takes the student through a series of pathways to fill in shortcomings or to jump ahead to make their time and learning material um, more efficient. We did that back in the 1970s with Plato. Some of you may remember the Plato computer system, Control Data, and the University of Illinois were a couple of the big players in that. Um, but so adaptive learning is what we're going to find uh, really blossom in this decade. And in the decades that I did teach, um, as I taught classes, I would aim at the middle of the class. It wouldn't be at for the top students because then I'd leave some behind. If I aimed at the bottom of the class, then I would create boredom for some of the students who were more advanced. So you always aimed at the middle, and then you tried to make do for those on either side. Um, AI really creates that personalized learning opportunity, and that's been our holy grail in the personalization of learning. Well, no discussion of AI now is complete without looking at the impact of quantum computing. Quantum is going to make such a massive difference. It's kind of like where we are with the cell phones. I mean, cell phones have changed our lives in ways that even now we don't even think about. But if we went back 25 years to a bag phone that we maybe lugged around, we would see how different it is. A couple of great little videos here for you to look at. But probably the turning point was this last summer when quantum supremacy was declared by let's see, I try to recall, there was a Summit computer that was Summit based in Tennessee, with the fastest supercomputer was beaten by a quantum computer. They gave the same problem to the fastest supercomputer in the world, and it was to identify a set of unique prime numbers. Summit, which is that fastest supercomputer, said it could come up with the answer, but it would take, gosh, just about 10,000 years. The quantum computer came up with the answer in 200 seconds, and that's the difference. The quantum computing can make a huge difference. And when we say quantum computing, and I know, Tom, we want to get to questions, so I'll kind of start closing things up with this. But quantum computing is different because we're all used to our computers, which have bits, binary, a 1 and a 0. Quantum computers have qubits, Q-U-B-I-T. Those qubits have ones and zeros, but they also can be 1 and 0 at the same time. And they can actually have a different rotation or phase at the same time. So it has multiple states. Hence, what it can do is so much more with each bit, each qubit, than what we've been able to do previously with the binary bits. And finally, Einstein called it spooky because the theory was there already about quantum entanglement. And I'll leave our formal discussion with this. It is that spooky quantum entanglement, if you take two qubits and you entangle them, put them together, then separate them and send one out in space, 10,000 miles, whatever, and you do something to the qubit you have, instantly the qubit at 10,000 miles does the same thing. Scientists don't know just how that happens. And when I say instantly, I mean faster than the speed of light. The change takes place faster than the speed of light over that distance. And so how does that happen? But it gives ultimate security. So there's a lot there. Well, okay, I'm ready to pause and start answering some questions.
Thank you very much, Rae. This is a fascinating taste of the topic that you're going to be presenting at the conference. And we have some questions and comments that have come in, and I'll turn it over to my colleagues who are going to read off from some of them and engage in a little conversation.
Thank you.
All right, thanks, Tom. Our first question is from Tony, and he asks, can we use the example of autonomous cars and apply it to autonomous learning and courses?
Yes, yeah, sure. So autonomous cars, I think the equivalent really goes into adaptive learning, so that as autonomous cars make decisions every millisecond, do I move forward? Do I accelerate? Do I stop? Do I slow down? Do I turn right? Do I turn left? And all. Well, with learning, the analogous issues are, I have this concept, it's in my learning outcomes, so I need to test the student or somehow identify whether the student knows that concept. And then do I move forward as in a car? Do I stop? Do I take a right turn and do a little detour to bring that student up to speed on this? Or by the nature of their response, can I leapfrog forward and move to more advanced learning? So yeah, there's certainly a lot that we can take from autonomous car research.
Okay, fantastic. Our second question is from Yolanda, and she would like to know, how does online learning and distance education fit in?
Yeah. So where we're going with this is once again adaptive learning. So these would not necessarily be well. Let me take one step back. These would be personalized learning. So it'd be learning for the student. One could still have uh, the equivalent of social discussion boards that would occur in parallel, but the actual learning, the learning of materials, and I shouldn't say actual, but the learning of materials will be driven by adaptive learning. And then it would be reinforced and we get additional information and networking with the students. So the adaptive learning will be driven by the algorithm of the artificial intelligence. And where quantum comes in is it supercharges that. It moves that forward so quickly.
And our last question, with AI and adaptive learning, does the role of the faculty and instructor become that of a tutor more so than a teacher?
Yeah, I think that's a really good question. In a sense, it's a tutor. However, uh, rather than it becomes much more individualized. So yes, you could call it is more of being a tutor. On the other hand, the instructor may be the one who designs the content of the class, and the instructional designer helps implement the AI. So the faculty member would determine what content needs to be taught, what are the outcomes, all of that comes up front. The interaction with the student is really using that instructor to help students, either to challenge them to move to their capability for those advanced students, or to help students who are struggling with something in the materials. So, the student benefits, and it is probably more than anything, it is student centered. It's all about personalized learning, student centered personalized learning.
Fantastic. Well, we want to say thank you to everybody who has been here on the live webinar. Thank you to Rae Schroeder, our presenter today for this DT&L talk, and for those of you who are watching the recording as well. This has been a great idea to just have one big idea, a little taste of it. And I know that on Rae's website, and we'll just post that into the chat here as well, on Rae's website, he has his contact information. So if you'd like to continue the conversation, I know he's open to that, and we're grateful to him for that as well. A little quick commercial here. We are very happy to share that we also have, forgive me, I got to put one more thing up on the screen. Here we go. We're happy to share that we have got online learning programs that we do throughout the year. And we also have that distance teaching and learning conference that we've made reference to a couple of times. And that happens every August. There's the screen. And you can learn more about it at go.wisc.edu/DTL. So thank you again, Rae, for a lovely DT&L talk. And we hope that we'll see you all online somewhere else, as Rae says, faster than the speed of light. Take care and enjoy.
Thank you.